Okay, great. Good morning, everybody, and good afternoon for some of you. My name is Jennifer Joyce, and I'm the Regional Vice President of Sales for the Western Territory here at Conducive Technologies, talking with you today about how you can achieve 2x faster SQL experience, guaranteed. So this webinar is really going to be broken out into two parts today. Now, the first part is we're going to just kind of frame as the thought leadership portion of this webinar, and we're just going to dig in a little bit under the hood, under the technology stack, and dig into some of the details about some of the I/O inefficiencies and I/O degradation issues that are really kind of occurring in the environment if you're running SQL Server particularly, and especially if you virtualize that environment. It applies to both physical and virtual, but our conversation track will be really focused around that virtualized space today. But if you've got some physical servers sitting there running SQL, this will equally apply there as well. So now, what is really happening under the hood that's stealing the underlying IOPS and throughput that's causing your underlying sub-storage system to work just a lot harder than it should, and ultimately why you're getting less performance than you actually should on your SQL workloads. That's really what we're going to be exploring today. So there are some inherent I/O penalties that we'll be bringing to light, and once we've given you that overview, then we're going to just take a real quick run through, not more than 10 minutes, just a real quick run through an overview of what our software does. And it really is just that. It is set and forget software utility. It runs in the background silently on Windows servers, and it's really designed to tackle those I/O inefficiencies that we're talking about solving so that we can guarantee, and at least to our customers, a 2x faster SQL experience. And obviously the compelling event around that is that getting more performance out of your SQL servers rather than just having to buy expensive hardware, and you just keep hand over fist throwing more and more hardware at the problem. Where our unique solution can come in is actually solve that problem with this 100% software-only approach. And we'll be giving a complimentary NFR, not for resale copy, that's worth more than a $500 MSRP value to you after the webinar is over as a thank you for attending. And, ultimately the proof, it just really is in the pudding. And so on the line with me is one of my cohorts and partners in crime. This is, I'd like to introduce you to Senior Director of Systems Engineering, Howard Butler. And for any of you car fans out there, if you're ever on a one-on-one call with Howard, chat him up a little bit, because not only does he specialize in accelerating performance in computers, but he is also a race car instructor. So he specializes in accelerating fast cars as well. So Howard.
Well, thanks very much for that introduction, Jennifer. Welcome, everyone. I hope that this short little webinar will be informative, and we look forward to answering any and all of your questions throughout the course of this presentation.
Yeah, and to just, thanks for mentioning that, Howard. We do have a Q&A box here in the webinar, and there is an option to send the comment questions to all panelists, so please do send to all panelists so that we can both see your questions. And we really want to keep this, this session as interactive as possible, so we will move to a full Q&A at the bottom of the hour, but, as some of those questions start rolling in, we'll address them as we go along. And, if you're thinking the question, probably someone else is too, so if you just throw it in that chat box, that would be awesome, and we can get to those as we go. Now, I will say here just real quick, Dawn, that WebEx has changed the format on us, and the normal place I would see to advance the slides isn't showing up to me, so I'm not quite sure how to advance the slides on this, Dawn.
Yes, the UI changed. It should be off to the left. It's very small.
Ah, I see it.
Yep.
All right. How many engineers does it take to advance a slide? Okay, here we go. All right, so so kind of picking back up here then. So, a lot of you who have joined the webinar today, you may have joined the webinar not ever having heard of Conducive Technologies before, and you may be kind of scratching your head going, well, who are these guys? Why do they even think they have the place to be coming in with some thought leadership to speak about this topic that we're talking about today? And, I'm, for one, am not a big fan of when companies spend an inordinate amount of time on their corporate slide, because I like to get right into the content, but I think it is irrelevant just to give you a real high-level taste of kind of where our street cred comes from. So we are a 35-year-old software company, and we are, from what we can figure out, the 12th oldest software company in the world. So that's saying something. And We originally started as a company called DiskKeeper. Some of you may have heard of that. Many of you may have even used our software to optimize hard disk drives. But about 5 years ago, the company brought some really revolutionary intellectual property into the marketplace. And it has absolutely nothing to do with our legacy DiskKeeper defragmentation strategies. But what we do now is we're all about reducing the noisy I/O. And it ends up that a lot of the I/O that Windows generates is completely unnecessary, and that translates over into that SQL Server system as well. What we've deduced is that about 30 to 40% of the I/O traffic it's just pure noise. It's just stealing IOPS. It's just stealing throughput. And in fact, those customers of ours who add just a little bit more memory server side, a lot of times there's already enough memory there, but when we want to do a little tuning, we just add a little bit more memory server side to take even more advantage of our software. And we see that those who have the right amount of memory in there are offloading 50% or more of the I/O from storage and just serving it from the server side. We just call this server side optimization to get that above kind of 2x faster gains experience. And for this work, Gartner named us Cool Vendor of the Year. And this was right after we launched the product into the marketplace about 5 years ago. And it's had really nice market growth ever since. It's now used by over 2,500 mid-market to large enterprise customers. And, you know, various iterations of this technology have been OEM'd by Samsung and Dell, Lenovo. You can kind of see the list there. So if you haven't heard of us, you certainly have heard of them. And we also have very close relationships with Microsoft and VMware. And this is a big one. Howard, I know you were closing, you were really closely involved with this initiative a couple of months ago, where Microsoft named us the first ever, I believe the first and still only ever software vendor certified for their SQL I/O reliability program, and that's usually reserved for kind of the big hardware players. So I think this was a pretty big deal.
Absolutely. I meant Microsoft's I/O reliability certification was primarily developed for those hardware vendors, those big iron companies, to showcase what their technology from a hardware perspective can provide to the performance and reliability of SQL. But we were also asked to participate in their certification process to just see how well can a software product, a software-only solution, assist in ensuring stability and reliability with SQL. And we clearly went over the bar and was able to achieve the same results that many of those hardware vendors were claiming.
And that's just awesome, just with a 100% software approach. So, before we jump into the thought leadership portion of this, let's talk a little bit about what's actually happening to create that noisy, unnecessary I/O traffic, and kind of, what this I/O degradation issue is that's really stealing the performance. And let me just give you a couple of quick opening slides on some really interesting information. Hopefully you guys will find this interesting as well. So earlier in the year, we conducted what we believe is the largest independent study conducted on I/O performance by over 1,000 IIT professionals. And we got responses from over 1,000. And we asked a bunch of questions, but there was one very pointed question in particular, and we said, regarding all these hard-hitting apps running on SQL, how many of you have performance problems so bad that you're actually getting staff or customer complaints due to the sluggish performance, like slow queries, slow performance, just, batch jobs taking too long? And if you look at the graph, you'll see that 28% of all organizations raised their hands and said, yep, that's us. And they were suffering from some sort of a slow SQL performance somewhere, somehow. So we've done the same survey now for the past 2 years. In fact, the survey is going out again right now. I just actually shared it out on my LinkedIn just this morning. So we're getting that survey going again. And, the numbers slowly continues to worsen. Now, last year it was 27%, this year 28%, not demonstrably different than last year, but you can see kind of the slow creep of this I/O performance gap between what we demand from an application and what the underlying storage is actually being able to deliver on I/O performance. So likely, if you're on this webinar, it's because you might fall into that 20 to 25% range. You've got a lot of company, and no surprise, no surprise if you're here because you're one of those 1 out of 4 organizations having this issue. And we have seen this issue, by the way, across all sorts of storage, whether it's, you know, tiered or all flash, that type of thing. So it really is kind of universal. Now we also asked this next question, and it was to name what apps are your most IO-intensive apps that you support that you have the most challenge in supporting and that you might be running into the most performance issues with. And we did a word cloud, so you can kind of see the results there. SQL just keeps rising to the top along with a lot of other heavy database type applications. And that's really one thing I want to point out. While this webinar is really focused on SQL, we do specialize in optimizing really any IO-intensive system. Our sweet spot is SQL, and that is because just of the inherent inefficiencies within SQL. We'll talk a little bit more about that. But you know, really 7 out of 10 of our new customers do come to us because of SQL, and then they go from there. Now let me just jump onto the next slide. So before I give you the picture of what is actually occurring in creating the IO degradation, it might help just to kind of have a perspective of what a healthy IO profile should look like. Now what I've brought up here is what we're really going for that optimal IO performance profile. And as you can see here on the screen, this is obviously very rudimentary extraction of your IO profile, but I think the takeaway is pretty obvious and immediate. And that you can see that what we want is nice, large, contiguous writes and then subsequent reads. And with that, you'd see that you're getting a pretty healthy payload of data with every IO operation. And you can notice, you know, just kind of how nice and sequential that looks. It'd be very easy workload to process. And this would be an optimal IO kind of relationship of data to IO. And especially when you have it now flowing down to the flash hybrid or tiered storage. But when you have a physical server, it's a little bit easier for the dedicated, you know, standalone storage of that physical server to address IO in general. But the moment that you virtualize, it gets a little bit of a different story. And what we're talking about, I guess this is what we want, but what we actually get is on this next slide. So what you see here, and I think you've got some immediate takeaways visually from what this slide looks like. But really, you're looking at an IO characteristic profile that's just much smaller. It's more fractured. It's more random, much more so than it needs to be. We'll just refer to this as a kind of a death by 1,000 cuts scenario, where your underlying architecture is processing workloads, but it's also having to process and overwork to process that workload. It's because of this IO profile. It's kind of like, I don't know, like pouring molasses over your flash storage, your hybrid storage, or your tiered storage, because now you're penalizing performance with what we call the perfect trifecta of the bad, you know, it's like a bad storage performance. The small, fractured, random IO characteristics. That's that perfect trifecta. And now what we'll do is we'll go ahead and dig in under the hood and see what's actually going on that's causing this. And we want to take a look at 2 different aspects of the IO penalty that's occurring that's causing this, this breakdown or this degradation. So the first one I'm going to talk about is right here, this IO blender effect down here on the bottom of the slide. Now, it's likely that you've heard of the term. It's a term that we helped Gartner coin a little more than 5 years ago when virtualization was really kind of spreading across the landscape. And the IO blender effect is basically what happens the moment you virtualize more than one server, the moment you put more than one server on a host hypervisor. So like I mentioned, on a physical server, standalone dedicated storage to that physical server, you know, that relationship between IO and the OS, yeah, it's small, it's fractured, but you're not getting the randomization. It tends to be a bit more sequential. But the moment you virtualize and you add more than one server to that host hypervisor, there is no fix for what happens apart from what our software does. And as great as virtualization has been for server efficiency, one of the biggest downsides is that it adds complexity to the data path. And the host hypervisor now mixes and randomizes otherwise sequential IO streams and now delivers to storage a more randomized IO pattern. And the moment that you add a third or a fourth VM or so on, guess what you're doing? All you're doing is compounding and amplifying that randomization effect. So, you know, this kind of has a slow creep aspect to it. Most organizations don't see the performance penalty that comes with virtualization and adding the complexity to the data path that I'm talking about because they tended to have virtualized slowly over time. But some of our biggest and best customers are those that kind of flip the switch. They went from 100% virtual physical to about 100% virtual overnight. And Howard, you know, a good example of this is a customer of ours that you and I have both worked with, Christus Health. They're one of the top 10 healthcare providers in the U.S. located out of Texas. And they kind of did this route. They virtualized one particular environment hosting over 2,000 VMs, well, servers at the time. They kind of went virtual overnight. And Howard, I believe you were closely involved with that, and you have some good insight into that event, right?
Sure, exactly right, Jennifer. I mean, you know, it's no secret, you know, when people go thinking about virtualizing and so forth, they build out their infrastructure based upon their prior knowledge of how things were working in the physical world. And then as a result, many times they're adding so many more virtual machines that they're forced to augment or upgrade their hardware at the same time. And this was one of the dilemmas that the large customer that you spoke about, they were facing a $2 million hardware upgrade for their storage. And that was a pretty tough pill for them to be able to swallow. Once they heard about our technologies, they wanted to investigate and look at it to see, was this really real? And, you know, they can do many things. And I think, you know, a question came up here from one of our listeners, from Eric Holzer, which asks about, you know, 4K alignment and, you know, having multiple virtual machine disk controllers. Sure, you can spread the I/O workload out across multiple storage devices, multiple spindles, and so forth, but you're not really addressing the root cause of the problem. And, you know, that's what this large hospital environment was faced with when they were doing the virtual or physical to virtual transition there. When they installed and looked at our solution set, one has to step back and understand that applications that are running on either the physical Windows servers or even the guest VMs do not talk directly to the storage device. Okay, let me say that again. Applications do not communicate and talk directly to the storage device. They must go through Windows. And so an application communicates its desire to do a file open or write request or a read request of data. It hands that request off to Windows. Then Windows has to process it. The file system within Windows processes it. It sends it on to, in the case of a virtual machine, to the hypervisor and host. And there is no coordination or prioritization amongst guest VMs to say this I/O, let's say, for example, is a SQL I/O, is far more important than some general user who's typing in Notepad. So all I/Os, once they hit the hypervisor and physical host, are going to be treated equally, and they all take up bandwidth and associated time and causes the storage system to be far busier than it needs to. So by placing our software in the mix there to help improve the efficiency of Windows, reduce that Windows I/O tax that you're seeing here, so you have larger, more sequential type of reads and writes, then you're going to certainly reduce that blender effect and have fewer I/Os going from the hypervisor and host out to the storage, which now the storage system can focus its best efforts on the real I/Os that have to take place and not all this extra noisy work.
No, that's great, Howard. Thank you for covering that. I really appreciate that. And Eric, thank you as well for your question. And that does remind me, any other questions on your mind, please start dropping those into that box. And again, we'll keep this about as interactive as possible and keep rolling through your questions. So we'll go on with a little bit more here on the conversation on the slide deck as you guys start putting your questions in. So you know, with what we were just talking about with the Christus Health, you know, we have a published case study with them about how we doubled performance for them, and we just republished and reissued that case study actually because we were on site just a little while ago, and they're now running us on over 2,500 VMs. So we just refreshed the case study to mention kind of the expanse to which they're using it right now. And you know, and as difficult as that penalty is, there's actually a little bit of a worse penalty happening further up to the top of the stack. And that's what Howard was just starting to really talk about, and that's the fact that that we have the inefficiency generating from the Windows operating system itself, and nothing that we do with our hardware, however we configure it, however fast it may be, will get rid of that or you know, touch on that, or solve it. So we've made allusion to that, but we're the ones who can actually explain it because we've got that expertise in this space with the relationships we've had with Microsoft over the years. So the Windows operating system, you know, as we've been talking about, it just does not play well in that virtual environment, especially when it's extracted from the physical layers. Howard was talking. They just don't talk to each other. So, you know, there's some severe inefficiencies in that handoff of the data between the Windows OS and the underlying storage. And as Howard was mentioning, there are no APIs that can connect the two. You know, it's just Windows still using its rudimentary framework to issue out these messy, floppy IOs to the environment. And where it really could be, and getting just a little bit deeper into this, where it really creates a serious problem, is that the Windows operating system, for any file that is being written, where it could do it in 1 or 2 or 3 IOs, it actually will inflate that. It'll break it down into much smaller pieces than it needs to from that file system level. And ultimately what happens is you're ending up in a situation where you're processing 4 IOs where you could have just processed 1, and that's the inflation that's really dragging things down. So, and Howard, I think we may have touched on this quite a bit already, but I just want to turn it back over to you for any other illustration that you want to provide on that.
No, I think that will suffice for right now. There are a couple of other questions that have popped up there. We may take those on the next slide or so.
Okay, sounds good. So, you know, another good example of what we're doing, and we've been talking about kind of tiered storage. You may have a tier 1 cache, you may have some slower disks below it, that type of thing. But we also want to focus on the guys who are already running all flash, and that's pretty important. And one of the other case studies we've recently published was with the University of Illinois, and their hardest hitting database was actually their Oracle database, and they were and also their SQL as well. And they were already running those on the latest Dell servers. They had the latest Dell compellent all-flash arrays in their environment. Their case study is also up and published on our website. And on day 1, it was going good, but about a year later, that performance had degraded to the point that they thought they were just going to have to go and open up the coin purse and go buy some more all-flash arrays to get more IOPS to meet their SLAs. But before they did that, they were looking for answers. They came across our software. The evaluation was free, so they figured they had nothing to lose. They installed it, and it more than doubled their performance in that environment, sitting on the existing all-flash arrays. And they just couldn't believe it because, you know, they had all this iron sitting under there, and it happens with a lot of our customers. It's shocking to find out how inefficient the Windows operating system really is and how it can drag down even the best big iron that's out there. So we're going to just move on to the next slide here, and we'll talk a little bit here, you know, as Howard and I, did that actually advance? It maximized it. I didn't get the advance. There we go. All right. So we'll talk about this, the next one here. And, you know, as I mentioned, Howard and I will just give a very quick overview of how our software solves this. We won't go over it in too depth, but just high enough here. And after that, we'll talk about the handoff of the free copy, the NFR that we'll be sending to you so that you can download it and install it seamlessly. It takes no more than 5 minutes, no reboot required in your environment so that you can start seeing the benefit of V-locity, the IO reduction software that we're going to send you. And it really is set and forget software. You literally just install it right into the Windows operating system. It's a very thin filter driver, very nominal overhead. We call it near zero overhead. And we would even challenge you to put it to the test to see if you could find the CPU footprint that it's using. It's enormously lightweight. And the CPU resources it does use runs at the lowest priority possible, so it's just not going to interfere with your server performance. We're there to speed you up, not slow you down. And so what the software is actually doing is offloading I/O from the underlying storage, and then at the same time, whatever I/O does remain, we're streamlining the remaining I/O traffic. So it's a friendly I/O profile for your storage to process. It's just much quicker, much snappier. And we do a couple of different things to do that. We have 2 patented engines within the software that you should be aware of. Now, the first engine is a write optimization engine, and then the second one is a read optimization. So we'll separate those 2 very clearly, the write optimization and the read optimization. So we're doing, you know, Howard, what I think we should do is start with the write optimization engine. Now, we've already talked and covered about the issue that Windows has and where it's looking for just the next available allocation at the logical disk layer. In fact, I don't think we really talked about that much. But what Windows is doing is just looking for the next allocation at the logical disk layer. And whether that allocation is the right size or fit for the IO, the file that you're trying to write, it'll use it. And what will happen is if you've got Windows, now let's give Windows some credit here. Windows in a freshly formatted NTFS volume, it probably will have the right spots for the ideal size, so you're getting the ideal IO performance on day one. It's freshly formatted, and the next available allocation is always the right size. And you're going to get nice sequential traffic. It's going to be, you know, an experience with clean writes and reads. But Howard, as time goes on and the files are written and erased and rewritten and extended, I think that's where the issue really begins, the degradation begins, and it starts breaking down pretty quickly, where, you know, if you're trying to write a 64K file and the next available space is only 4K, it's going to use that 4K chunk. It's going to split the file, and now we get into that IO inflation. That IO didn't have to happen, but now it split the file to find the next available allocation. It'll write it, split, rinse, and repeat until the file is fully written at the Windows NTFS logical level. And Howard, I think, you know, we have basically the technology here with velocities and Telewrite that will solve that problem and make sure that Windows is delivering every file with optimal density. So maybe you can share a little bit more with us of kind of the intelligence that we're adding here to force this type of behavior into the Windows operating system.
Sure, exactly right. And I think you've kind of touched upon some of the key components there. First of all, Windows is fully in charge of processing the I/O. We're not augmenting or changing the path of the I/O request at all. We're just simply providing the intelligence that Windows needs to be able to make a better decision as to what section of free space should be allocated for writing the particular data that's being requested. And, you know, again, this kind of ties back a little bit to some of the questions I'm starting to see in the Q&A box where, you know, Robert Grant was asking about, you know, I/O prioritization that might be done or VM prioritization being done in VMware. And part of the challenge is it's not necessarily about prioritizing I/Os. It really is a function of eliminating the unnecessary I/Os so that way the real I/Os that need to be done can be done so more quickly at the storage level. So what we have here is this level of inflation where Jennifer was speaking about, where Windows has no intelligence about how large a file is going to be or where the optimum section of free space to be allocated. It doesn't waste any time looking or scanning the disk, looking for the best possible fit. It gets an I/O request from an application. That I/O request then will be sent down to the Windows NTFS file system, and as a result, it goes and grabs the first available free space. So like Jennifer said, if the disk was freshly or newly formatted, the next available free space is always going to be pretty large. So therefore, it'll be able to write what data it can, then it'll go to the next I/O request, and so on and so forth. But over the course of time, as you created files, as you've deleted files, as you've modified files, all of this takes place in that very dynamic Windows logical file system point of view. It's not really happening down at the hardware. The hardware actually handles where they decide they want to place the data in the physical universe, okay? But an abstract layer of that storage environment is what Windows is using. That is the Windows file system. And when it goes to allocate space, if the next available free space is 4 KB, but you're trying to write, let's say, like Jennifer said, a 64 KB size file, you can't write store 64 KB in such a small little tiny postage stamp space of real estate. But what Windows will do is write what it can, tie off, go and allocate another section of free space, write what it can, and continue on down that process. And that's that inflation of I/O activity that's occurring on writes. And however you write the data is the same penalty you're going to incur on reading it back. So part of the beauty here And the simplicity is that if we can help Windows write the data more efficiently from the very beginning, you're not incurring the penalties on the writes, and you're not going to incur those penalties back on the reads. And you're not having to defrag or clean up the file afterwards either. This is all done so the file is written the first time in the most optimum fashion, such that it requires the fewest number of I/O requests.
Well, and Howard, one of my favorite analogies that you use on that is kind of the example you use when you talk about a gallon jug of water.
Well, exactly right. I mean, if I gave someone the task of taking a gallon of water and moving it from one side of the room to the other, okay, you have your choice. You can either move it in one big giant gallon container and just walk across the room and set it down, or do you think it would be more efficient for you to take an individual Dixie cup, 1 ounce at a time, and go back and forth across the room until you've transferred the entire 1 gallon content to the other side of the room? So, you know,
Howard, obviously the Dixie cups are more efficient.
Well, it depends on how you're looking at things, that's for sure. If your job is to sell more Dixie cups, then go for it.
That's right. I'll take the gallon jug any day. Well, thank you very much for that illustration. Go ahead, Howard.
Yeah, and this technology, in fact, all of our technologies work equally well, whether you have direct attached storage, whether you have SSDs, whether you have any type of mixture of spinning and SSD type storage devices in the same RAID array. It works equally well when you have hyper-converged type of storage environment because it's the same flavor of Windows. You're not buying a different flavor of Windows for all of these different type of storage architectures. Windows is Windows, and this is where the problem creeps in and where we need to insert ourselves to optimize the behavior of the file system at the root of the issue, not subsequently further down the chain, down the stack at the storage level. So again, you know, one can try to compensate for this level of inefficiency by just buying more and more hardware and spreading the workload out across more spindles, faster spindles, or faster type of storage media, hyper-converged environments. But the reality is you're not fixing the real problem. You're still left with the inefficiencies of Windows. So all that money you're spending for this extremely or I should say sophisticated technology, you're not getting the full money's worth. And so as a result, our technology is positioned and poised in the right place to solve this problem, which is a file system issue, not a storage media issue.
No, that's excellent, Howard, and I really appreciate that. And I'm just going to mention again, thank you for all the questions. We will do, there's so many questions coming in. This is wonderful. Keep them coming. We'll go ahead and get through the rest of the content, and then we'll come back and efficiently answer these questions since we've just gotten past the bottom of the hour. If anyone has an obligation and they have to drop off, no problem. We will send you a replay link of the webinar, but we do have a couple more important things we want to cover real quick. So, Howard, kind of the net takeaway that I'm getting from this is that really the intelligence that we're feeding into the Windows operating system just helps the Windows OS, best allocate at the logical layer, since, normally the next space is rarely, if ever, the right size. And, as powerful as that engine is, what we want to do is just make sure that we talk about the second engine, because as good as that one is, there's another one that does an amazing job as well, and that one is our read optimization engine. Now, this engine is very, very different from the first engine. And it's actually DRAM read caching engine that we use to establish. I mentioned earlier you may have a tier 1 cache strategy in your storage. Well, this will establish a tier 0 cache strategy in your environment simply by leveraging the idle available DRAM sitting right there on any given VM or physical server. And we're just utilizing that memory that's sitting there doing nothing otherwise wasted, and we're using it to serve hot reads. And the real genius of this engine is that it is completely automatic. We do not have to carve out or allocate any memory for this caching engine. You're just going to tap into what's already there. And the software is really designed to be aware moment by moment of how much memory is unused. And at any given moment, it is only going to use a portion of that free unused memory to serve hot reads, so that you're never going to have to deal with an issue of resource contention or memory starvation, because you know, the intelligence of this engine is completely dynamic. It just rolls with it, with whatever's available. Now, obviously, if you're writing a heavy workload and your memory is constrained and you're under peak loads, let's say it's 3 p.m. under peak loads, well, then this caching engine is just not going to kick in. It'll sit on the side. It'll back out if that demand starts increasing. If your system memory is constrained, let's say a different scenario, but you're not using quite all of the memory, you do have just a little bit left over, well, we'll be able to use a portion of that that's a little bit left over, and we'll put that to good work. And other times there'll be plenty available, and we'll really go to town with that. So, you know, now sometimes I know that when people hear and they're thinking about, you know, read caching strategies, that they're really thinking it has to be capacity intensive to be really effective and really take advantage of the caching, and that just isn't true with our design. And Howard, I know we found that if customers maintain just 4K of free available memory on some of their systems, 4 gig is what I meant to say, that oftentimes that will serve up to 50% of the read traffic from storage. And so it's not always about being capacity intensive, and especially because our behavioral analytics engine is so powerful that we can leverage just a little bit of DRAM, keeping in mind that reading from DRAM is going to be 10 to 15 times faster. Reading from this Tier 0 cache strategy is going to be 10 to 15 times faster than even reading from kind of your Tier 1 SSD layer. So just a little bit of capacity up here can have a huge impact on offloading a lot of that noisy I/O and a lot of those hot reads that would otherwise have to go down the storage stack and back. And Howard, let's hear a couple of your thoughts on this to expand a little bit.
Well, I think you're absolutely right. You know, with our technology, it's not necessarily about how much of your data we cache, but how much of the unnecessary or small, noisy read IOs that we're able to eliminate from having to go to storage has a tremendous impact on application speed and performance. Storage technologies today work quite well. They have a lot of sophistication and capabilities, but what still drags them down is the constant flux or change of I/O traffic patterns. In one regard, if an application is generating a few large IOs, sandwiched in between those, these really tiny, small I/O requests, that's the most difficult type of traffic pattern for most storage technologies to deal with. And if we can recognize that a lot of that read I/O traffic is repetitive, and most systems today, in today's real world, are built out with at least enough memory to have some extra memory that's not currently being used. Memory's kind of cheap in today's real world. That most systems are a little bit over provisioned when they come to think about memory. That we can harness and leverage a portion of that memory that's unused and be able to recognize the data patterns, the I/O traffic of information that's repetitively being requested. And this is not always just within the application. There's lots of I/O traffic that's occurring outside, let's say, the scope of SQL, or outside the scope of Oracle or other applications that is often repetitive. And if we can satisfy that I/O traffic from memory, memory-to-memory transfers being, 10 to 15 times faster, like you spoke of in regards to SSDs, but it really is that elimination of the I/O traffic from the storage stack, such that the storage environment now is getting larger, more sequential IOs, both for reads and writes, by us being able to cache a good portion of the read IO requests. And again, this is done very dynamically, so you're not having to carve and set aside a fixed amount of memory for us to use. If you have an overabundance of memory and it's not being used by applications, great. It's fair game. We can use it and put it to good use. We will also recognize that we can't use all the memory on a system, because then that causes Windows to start thinking that it's running low on memory and try to reclaim or recover some memory from other processes and so forth. And we don't want that to happen. So we will always leave a sufficient amount of free space untouched by our caching engine such that Windows is happy, applications are happy, but if there ever is a demand for even more memory to be put in play by those applications, we will detect that condition occurring and even flush entries out of our cache and give memory back to Windows so applications never see a memory starvation.
Yep, and you know, and Howard, I'm guessing that we probably have at least one person, if not more, sitting on this call. Haven't read through all the questions yet, but Howard, as I cover the next things, maybe you can start glancing through those questions so we can answer those quickly. But I'm sure that there's at least one person sitting on a call going, yeah, but I've got 100,000 IOPS or 200,000 IOPS, and you're talking about reducing, you know, 30 or 40% of I/O, but I'm only using 10,000 of my capacity. That's a really good question if anyone was thinking it. And just to give a quick example of that, you know, I'm 5'3", so just kind of telling on myself there, but I'm 5'3", and when I walk into a room and it's got 20-foot ceilings, I cannot use the 15 feet of space above me to get from one side of the room to the other. What I'm focused on is all the people around me down at my level. And that's what we're focused on as well. We're focused on the I/O that's happening right now. And right now it's a mess. We come in and we clean that up. Whatever the capacity is above is immaterial. We're talking about actually shifting and changing the nature of the I/O, making it larger payload per I/O, cutting out 30 to 40% of the I/O down here in this 5-foot space that we're actually living in. So if we're able to remove 30 to 40%, if not more, of that I/O through our write optimization engines and our read caching, when I enter the room, I'm going to be able to navigate across to the other side of that room much more quickly, and you're going to get that faster throughput. So we're going to shift gears here and kind of wrap things up and get you to your free software downloads and talk about best practices for that. And if you're a Gartner client, you can really check in with them. You know, they call us the world leader in DRAM read caching technology, and we can't say for sure that we are, but we believe that we've sold more caching licenses than any other player in the marketplace. So I'm just going to outline just a couple of these real-world case studies for you. One of these here, ASL Marketing, is a good example. I got to do the installs with them myself. That was kind of cool. And they had a huge batch job that they would do, and it had literally millions of records, and it was taking them 27 hours to complete. This happened to be in a call center, and they needed it done overnight. It was not working out for them. So they didn't have the budget at the time to rip and replace their hybrid storage with all flash, so they tried our software, and we cut that down from 27 hours to 12 hours. And I was lucky enough to be the one to take the call after that happened. Mileage varies. These are spectacular results. Not everyone's going to see something so spectacular, but it was a 15-hour reduction, and they couldn't believe it. Another example, Stockport College, something similarly spectacular. It was taking an average of 15 minutes to process one student record on enrollment day. And again, no budget to really rip and replace all that hardware. So they also had the systems crashing because of the I/O load, and when they installed us, they got it down to 5 minutes. Then they rolled over to another application, and this one was hard to believe, but they also cut down an hour-and-a-half process down to 10 minutes on this other application. So not changing out the hardware. So it just underscores how inefficient these systems can be processing the I/O unless you're doing something to actively address it server-side right in the OS where that inefficiency is being generated. So there's a bit more here. You know, Alvernia University was another one, 3,000 students accessing an LMS package, students taking tests, and they were getting timeouts in the middle of tests due to the I/O demands during those peak loads. And they didn't have the budget to rip and replace the hardware. They threw us in. This one, when you read the case study, is funny. It doesn't happen often, but someone actually walked up to our contact and said, dude, what did you do to the server so much faster? So that was pretty neat. So let's take a look real quick at a UI screenshot of the software itself. And, you know, really this is the benefits dashboard. And what we want to see in this dashboard is what the software is doing for you. Now, on the screen in front of you, what you're looking at is the median results of a typical system that has just 4 gigs of free memory that I mentioned that we can leverage for the read caching. This screenshot was taken for data over a 3-week period. And as you can see, the total I/O is eliminated from storage in the top, kind of middle there. You know, it shows you the percentage of read traffic that they were offloading from storage, and you can also see how much we were offloading from writes. So eliminating 32% of writes, 64% of reads, and then the storage I/O time saved with that DRAM read caching kicking in as well. Excuse me. And now that's just a screenshot, so you'll see that when you download your own software. Now, the best practices, and this is probably some of the most important points we're going to cover, because now it comes down to the rubber meeting the road and you experiencing that 2x faster SQL experience yourself. And these are the steps that we feel must be completed to really let the software shine and give it its best chance for success in your environment. So step number 1 is just check out the DRAM that you have on the system. If you're already really, really highly provisioned, you probably don't need to add anything. But if it's a little skinny, we want to go ahead and if you can afford it in that environment, add 16 gigs to that VM. If not 16, then 8. If not 8, then 4. So every situation is going to be variable, but add what you can. And the next thing that you want to do, it's also very important, is that on SQL, you're going to want to cap memory. So if you don't already have a memory limit in place, as you're aware, SQL will gobble up everything you give to it, and it's not using it efficiently. And our engines will put it to much, much more efficient use with our advanced algorithms. So one of the primary reasons why SQL is such a sweet spot for us is because of its inherent inefficiencies. So our software, if you put that memory cap in place, our software will be able to get in there and have a chance to play and optimize for you. Now, if you're still here on the call and you want to say something like, well, it's a physical server, as I mentioned earlier, it's a physical server, or my host, I just can't add any more memory to it, it's memory constrained, then rather than adding memory, you may want to just cap SQL a little more aggressively with the memory already on that system, leaving 8 gigabytes above the memory line. And that'll give us a chance to get in there and do something effective. So most likely, like I said, you've already got enough memory in there, but if not, we want to recommend those adjustments as a very important step. And then thirdly, you're going to just let it do its thing. It really is set and forget software, and come back 7 days later and see what the dashboard is looking like. If you're not quite seeing those 50% numbers in there, then we want to revisit the memory and just make sure that we've done all the tuning there that we need to. So we will be getting you that NFR, and it should take you less than 5 minutes to install it, allow at least 24 hours for the algorithms to adjust, and then hop in there and review that dashboard. And that's kind of the highlights of what we wanted to touch on with you on the best practices. Another thing, though, is that if you do get in there with the NFR, and you want to, some people want to save that NFR. In fact, I just got off of a call with a customer yesterday. They're an existing customer. They use our product on their desktops. They attended one of these webinars for our servers, and he didn't want to burn up his free license, was kind of curious which server he should put it on. So we sent him our free I/O assessment tool. He did a run on 17 different servers. I hopped on a call with him yesterday, and we identified the server he wanted to go ahead and install that one license on. So he's doing that yesterday or today. Another option, though, is that you can actually get a 30-day trialware that you can use on as many VMs as you want. We really recommend using it on all the VMs on a host. And that trialware we can go ahead and send out to you. Just respond to us after the webinar and let us know you'd like to have that trialware option, and you can keep your free license in your back pocket to decide what server you really want to put it on later. But really, if you want to use our console, we'll send you that as well as part of the trial. It takes no more than 20 minutes to stand up the console and push it out to as many VMs as you want to test it out. So I think that that kind of takes us to the Q&A section here in just a second. So we're going to go ahead and shift over to Q&A. Now, I have some Q&A questions in my personal Q&A box, which I don't think is visible to all panelists. I will roll through those really quickly. And Dawn, I've got
Jen, you went silent there. Can't hear you, Jen.
Oh, I'm back. It looks like I accidentally hit my hang up button.
Okay, you're very hard to hear. You sound like you're in a tunnel. Try again.
Yep. Tell you what, I'm going to dial back in, but Howard, why don't you start taking those questions while I do my dial back in?
Sure, that sounds fine. So I think we kind of left off. I partially answered Erica Holscher's question about, what type of storage devices would we support, and anything that's connected to Windows. If Windows sees it as a local NTFS partition, then we're good to go. That includes SAN, DAS, NAS, iSCSI. All of those type of storage environments would work extremely well. He was also asking a question about network packet fragmentation, also causes these type of phenomena. It's not quite the same. The analogy is similar in the sense that if a network packet is insufficient to carry all the data and it has to break it into smaller and smaller pieces, if you're not using jumbo frames, that would be true. Apply this, though, that same type of logic towards disk I/O at the application as it's handing it off to Windows in the Windows NTFS file system. So it is similar in nature like that. Robert Grant asked the question, is your driver integrated or interactive directly with the kernel or through an abstract layer or interface? Our drivers are mini filter file system and storage drivers. They do sit in the storage stack. They provide a wealth of information back to the Windows file system so Windows can make better choices. It also provides us intelligent information on how to dynamically adjust the size of our cache and a number of other things there. So it is integrated within the Windows operating system framework. And let's see, I think Mike Wise asked a question, and this is a really good question, should our solution be installed on the VMs, SQL Server VM, or hypervisor to get best optimization? And it really would be all the VMs that's working on the same hypervisor or host system. So obviously you would want to target your highest hitters, those being the SQL servers and any other application servers that are generating high amounts of I/O traffic. And even the ones that may not appear to be that active, combined together, their efforts may certainly equal the I/O throughput that some of the heavier hitters produce. So we do recommend that you put our software product on all VMs in your environment, as well as any physical Windows servers that you're running your applications from. The hypervisor itself, nothing of our solution set really needs to be on the hypervisor, because if we're optimizing at the guest level, that's where you're going to get the most bang for the buck. Mike also followed up with that he understands fragmentation. He's asking the question, though, what is the source of the other noise? Well, fragmentation itself causes extra I/O traffic because of the inefficient writes and subsequent reads. But if your applications are reading the same data multiple times, that in itself is kind of a noisy, unnecessary I/O if it could be satisfied from memory. So if we can cut out that read request from having to go to storage and compete for storage I/O bandwidth, that's a level of noise that we can cut out as well. Let's see if I can roll down through a couple of these others a little quicker. Does your system increase or modify the read or write buffer size for the data controller? The answer is no. We don't change the size of buffer requests, but we will help Windows make better choices as to allocating larger chunks of data for those reads and subsequent writes. So we're not controlling them. We're passing the information to Windows so Windows can do a better job on its own. And I think there were some questions here from Eric again on how does IntelliWrite work with the underlying storage is virtualized and data deduplicated, such as Windows storage spaces, NetApp dedupe, Vmax, etc. We work extremely well in those type of configurations because we're not competing trying to do their jobs. We're just simply providing a level of efficiencies so Windows can do its job better from the very beginning. We're not having to go and defrag and touch all files that would have in prior iterations of solutions like this would have caused extra I/O traffic. We're not doing that. We don't need to move all the files. We only need to prevent the fragmentation from happening in the first place. And then those handful of files that may already be sufficiently or highly fragmented that we want to clean up because they are causing a performance problem, then let us have at it on those one or two files to do that cleanup work. You're already doing lots of reads and writes anyway, so it's not going to compete or cause any type of data dedupe or thin provisioning type of problems there.
And Howard, I've rejoined, and there's a couple of questions in my private box which are addressing licensing, which let me, if you don't mind, let me touch on those just real quick, because I'm sure there's some licensing questions here in people's minds before they drop off.
Sure.
The first one is the licensing done at database level, VM level, or physical host level? We have multiple licensing options. We can license this by the host, or we can license it by the VM or physical server, standalone server that is not virtualized. So you kind of can scale this up or down to meet your needs. If you just want to cherry pick a couple of key big I/O servers, just get a per VM license. If you want to get the overall I/O reduction kind of force multiplier effect across all VMs and alleviate that from all of the I/O from the storage, then you'd go with the host-based licensing. Robert Grant, I see your request for the trialware. We will get that out to you. Anyone that's going to go ahead and get the V-locity trialware with the VMC experience, let us know. And you'll get 2 emails. One, you'll get an FTP link to download that, and then the second one of our tech support guys will send you a trialware license to apply to that. And then there's one technical question from Chris in my box that says, is there a difference in Windows OS penalty on OS versions, say 2008 or 2 versus 2012 or versus 2016? No, the penalty is the same. This is such a core underlying behavior within Windows. It's just, it's so hard-coded deeply into Windows that the penalty is equal no matter what Windows OS you're running on. And by the way, for those of you running a VDI environment or even physical desktop supporting those, the same is true of the 2007 and higher VDI clients or physical desktops. So Howard, I'll come back to you so guys, we are at the top of the hour. We do realize that you guys have busy schedules. We're going to stay on and keep answering these questions. If you have to drop off, we will get you the recording, but we're just going to go ahead and stay on and keep answering some of these questions for a few more minutes. So Howard, back over to you.
All right, well, thanks very much. So I think where we were leaving off there was a question from Eric that also was asking whether or not we work with NTFS with other file systems such as REFS or Linux file systems. Currently, right now, our implementation is only for Windows NTFS file systems. So that kind of gives you an idea. As the world begins to more adopt REFS, then naturally we will progress in that direction. But we'll see how the rest of the world really adopts the use of that newer technology file system. I think Chad Brennan was also asking a question about fiber channel and writing to all SSDs. Is there any performance penalty or SAN overhead when using this technology? And the answer is no. There's not going to be any additional overhead. In fact, we're going to reduce the amount of overhead that you currently are experiencing because we're helping to eliminate, up to 50% or more of your I/O traffic from ever having to go to storage. So no matter what kind of storage environment you have, it's going to run better, faster, and more efficiently with our software in place.
Okay, Howard, let's take a few more.
Let's take a couple more. Robert Grant was asking a question about disk format or volume cluster sizes. And certainly as you increase the volume cluster size, you do reduce the probability of causing extra IOs. But there's only so far that you can go with that. And that even if you do have a 64 KB cluster size, the fact of the matter is you still may be doing a lot of unnecessary reads and writes. And so our technology will also help in that environment.
And sorry, Howard, and so he's asking specifically, does our solution highlight recommendations? And it does not, correct?
It does not highlight a recommendation, but that's something that we could always look at for some future enhancement.
Oh, great. And Robert's curious about what type of SQL workloads we've tested this on.
A variety of workloads. That's, different customers have different usages for SQL. SQL is, an enabler. It's a database storage type of construct, and it really is dependent upon the applications that the customer runs. But, you saw some of the comments from other customers. I mean, if they're doing lots of I/O traffic and they have at least some available memory for us to use for the read caching part of it, then I do expect that we will at least cut out, 30 to 50% of their I/O traffic.
And to add on to that, on Robert's question of what improvements do you have in query latency and response times, mileage varies. We have people test in a number of different ways. We have people test with their own internal measurement tools. Some people get out a stopwatch. Others are looking at some of the reports within V-locity. And ultimately, some want to just see how does it feel? Does it seem faster? It's really going to depend on how that SQL application was written and what you're doing with it. So mileage really does vary, and we simply have to install in your environment to see what we're going to get from your environment. Howard, I think we've touched on this briefly, but Chad wanted to know about 2016, if it's going to be helpful there as well.
Absolutely. We're fully supported on Windows 2016.
Okay, great. And Chad's got another great question. Appreciate all these questions, guys. He says, since V-locity is using DRAM for caching, what is required to stop the hypervisor from swapping DRAM to disk at the hypervisor layer?
So we're only going to use memory that on the guest VM, Windows sees as free and available and unused. So if it's unused, then we will put that memory into play. You have the same concerns even without our software in play there, that if you're using any type of memory ballooning or reclamation or dynamic memory at the host level, you're always going to be, conscientious or thinking about how to ensure that you don't oversubscribe your memory.
And I just saw Chad's comment about I/O having wings so it could use the other 15 feet in the room. I'm glad I didn't see that while I was talking because I think I might have lost it. So Eric, to answer your question on does this work in cloud instances, AWS and Azure, yes, it absolutely does. In fact, we had just recently wrapped up and published a paper with results in doing some Hammer DB testing in Azure and got really, really awesome results there because, again, this comes back to the core that Windows is Windows is Windows. And whether it's on a physical server in your private cloud or on someone else's server in the virtual cloud, these inefficiencies are so native and inherent to the Windows operating system that you just can't escape it no matter where you go, and we do provide value there as well. And keeping in mind that our software is fenced by the Windows operating system, so if you're in a Hyper-V live migration environment or a VMware vMotion environment or porting from P to V or going to the cloud, you're going to be able to take the software will just natively reside within that VM and go with it wherever it goes. Fail over into DR, into HA or anything like that, you're good to go. So that's a little bit more there. And let's see if we've got, we're going to go ahead and keep on. We've got over half of the people that originally logged into the webinar still on, so we have an interested audience. We're going to go ahead and extend a few more minutes here and see how many of these questions we can get to. Howard, does the agent store and allow central reporting for the data here?
Absolutely, it does. We do have a V-locity and DiskKeeper management consoles that provide that centralized reporting capability to roll that information all up to see it in one pane of glass.
Fantastic. And Eric comes in with another question. Does this work with bulk load copies like what Microsoft SACM uses for replicating data? We are using an instance with 256 gigabytes of RAM due to the heavy usage.
So again, we'll only use memory that Windows considers to be free, available, and unused. So we're not going to steal memory from those other applications and usages, and that we'll work with whatever memory you do have that's available and free.
And one aspect, Howard, that I usually talk about during the webinar, or you do, and I don't think either one of us touched on it, is what exactly is it that we're putting into that cache? And what we're putting in there, it has to be repetitive. We're targeting the small, tiny, noisy I/O. We are not bulk loading and just land grabbing tons of data to overpopulate the cache. So we've logged into many, many servers that might have 10, 16, or more gigs of cache free, and our cache is only built up to 1.5 gigs or 2 gigs. It's very intelligent and sensitive to making sure that it's relevant, hot, repetitive reads, small, tiny, noisy I/O traffic that's likely to be read again that we're offloading. So we're not just going to land grab and kind of grow that cache big just to grow it big. So we have several requests for people to send trialware. Let me see what other questions we have in here. So how does the NFR license work in a two-node active-passive cluster. So that's a good one. Typically, when you have a two-node active-passive cluster, you would license both nodes. Chris, I'll make a note of that. We can connect offline if you're still on the call. And then another question from Chris is, many of our production servers never have access to the internet. Does your solution remain self-contained and not make calls home or to the internet? Howard, I'll ask you to field that one.
I didn't quite catch the question there. Can you repeat that one again?
He's got an isolated network that doesn't talk to the internet, and is the software, so I think it's a security question concern, does the software call back to Conducive, send any data out to us, or if he's in a kind of a red isolated zone like a lot of our military or banking customers, how does our software work in that context of a kind of a cutoff network?
Perfectly fine. You can install V-locity. There is no call home over the network or over the internet. You'll get a license file that activates the product, and from that point forward, there's no further, there never is a need for the V-locity product to communicate over the network.
Fantastic. Okay, and so Mike, I've noted your request for the trialware license that will get you those extra emails. Prasanna, it looks like you as well are asking for that, but when you receive the email from our marketing team sending you your free copy of V-locity, you can respond to that email specifically and say, please also send me the V-locity Management Console trialware experience, and we will make sure that one of our salespeople gets that out to you. And so Carrie has also noted that. So Dawn, we have a lot of people who have raised their hands saying, yes, go ahead and send me that V-locity Management Console and expanded trialware. Do you have a capture of all of the Q&A from this webinar so that we can make sure get back to everyone who's requesting it in the chat box?
Yes, I do. I can see who's requesting that and make sure they get that.
Okay, that's fantastic. Chris has got a question. Is there a difference in performance with smaller versus larger files, databases files, and partition table types, MBR versus GPT? So Howard, I'll turn that over to you.
You know, the performance differential is going to be felt or based upon the amount of I/O traffic. The type of storage or how it's configured really doesn't have any impact on our product's ability to enhance or to improve the situation. So we'll work equally well in that type of environment. There's really not one way or another to build a stronger case for it.
Great. And then Howard, there's a question from Robert. What about SQL 2017 and older versions?
If they're running on Windows 2008, R2, and later platforms of Windows, we're good to go.
Okay. And then can it be used on SharePoint 2013, 2016, 2019 environments?
Yes. One of the things is we're not application dependent. It really is just an integration of Windows. If it's a Windows environment running Windows, as I mentioned, 2008 R2 or above, then we're good to go, regardless of the type of applications that you're running, because they're all interacting with Windows and the file system.
Fantastic, Howard. Thank you so much for your expertise in answering these questions. And we still have half of the audience on the phone, even though we've run this late with all this dynamic Q&A. So we want to thank everybody for your participation. This was a lot of fun. Really appreciate all of those questions. And again, you will be receiving emails with your free NFR for V-locity. Just reply back to that with any questions. Make sure you raise your hand for that copy of the software. We'll be calling through all the Q&A of the people who raised their hand already and said, yes, send it to me. And we'll look forward to working with you through the evaluation process. So I want to wish everybody a great day, and thank you for attending. And thank you very much, Howard, as well.
Again, my pleasure. Thank you very much.